Welcome to TopSolid 7. In this video, we are going to look at programming a part on an Okuma Multus U3000. The part in question that we're going to program is going to be this mechanical flange body. You can see there's operations all over the place that we have to deal with, and we're going to do our best to program all of these operations live together. The first thing that we want to do with this part is we want to create what's called a machine part setup document. In a machine part setup document, this is where I get to tell TopSolid what the part to cut is and what the stock condition of the part is going to be. In this case, I just want a simple piece of cylindrical stock, and I'm going to add a little bit extra material on the left side. Perfect. I'm going to save my work. Next, I'm going to start a new machining document. Here I'm going to choose my Okuma U3000 with chuck template. When I do this, you're going to see that my CAM file opens, and in here is my Okuma U3000. Now in this case, I've done a little bit of prep work ahead of time. I have my standard holders that I use already on the machine. I have some turning tools and some of my turning holders for my milling holders down here. I have them empty, waiting for the tools that I need to use. Cool. Now I'm going to zoom up here on the chuck, and we're going to take this mechanical flange body, again the machine part setup file for those of you watching at home, and we're going to drag and drop it into the model. I'm also going to use stock faceted mode here because it's just a little bit faster on the calculation. I'm going to position this off of that axis there. Perfect. I'm going to take that to this plane right here, and we're going to go ahead and offset that as well. I'm going to say, you know what, let's go back maybe that 1/2 inch, right? Perfect. That looks good. Maybe we'll go even a little bit more. How about 5/8? Nice. Now, from there, what I want to do is I'm going to take my plane here to this face. That'll close the jaws. And the last move I'm going to do is I'm going to orient that face to my x-axis. This way my part is positioned exactly as I need. Nice. Like that, we're now ready to start machining this part. In this first step, we're going to start by turning down the front face of the part. To do this, I'm just going to select the front face of the part, right mouse button click, and choose roughing from the turning section of my contextual menu. Once I do this, TopSolid's going to generate what we call the spun profile. Here it's going to calculate the real turning profile automatically for you. Depending on the part complexity, it may take a second or two, but now we have it. Now here it also chose a neutral tool in my B-axis upper turret because why not? We haven't done any operations yet, it doesn't know really what we want. So here what I'm going to do is change to our lower turret, and I'm going to choose this first tool. Now that I have the tool selected, I'm going to click my tool button here. I'm going to flip this down a little bit so we can see. And now you can see a preview of the tool path coming in. Next, I'm going to change my depth of cut. Maybe I want to take a 30,000 depth of cut. Nice. Just double click, make the setting change, let the tool path regenerate. Maybe I only want to leave 10,000ths to finish later. Cool. Again, double click, make the change, let the tool path regenerate. Let's go set some feeds and speeds as well. Here, for example, I want to work in constant surface feet. So I'm going to say I'm going to work at 750 surface feet and how about a 15,000ths chip load. And I'm going to set my maximum spindle speed for this to be maybe 3,000 in this case. And like that, my roughing is now complete. The next step is to let the software go into a simulation mode. And here you can see we've indexed the turret and we're bringing that forward, and you can see the first roughing cut is complete. Okay, the next step, what we're going to do is going to get out of the simulation from the previous step here, and we're going to go ahead and turn down the length of the part. Now, when we do this, we're going to use the upper B-axis. Not for any other reason than we can, and to show you different ways of working within TopSolid. So I'm going to start by selecting the face I want to start turning at, and then using the Alt key on my keyboard, I'm going to select the end face that I want to finish turning at. And I'm going to right click and go to roughing. Now, what TopSolid's going to do in this case is it's going to pick up the roughing, it's going to pick up our tool, and it's going to generate our preview. Now let's look at our preview for a second because this is kind of neat. Here what's going to happen is we are going to turn down the part, and notice based on the tool orientation, this is showing the real condition of the part. From here, what we want to do is we want to maybe take this B-axis head and we want to rotate it 45 degrees. Nice. So to do that, I'm going to come into my comment section. And down here, these are just standard angular solutions. You can see as I click this, it turned the tool to have the insert facing the other way. Maybe what we want to do is we want to set this at 45 degrees instead. So let's hit New Angular Solution, and let's go to B, and let's just simply type 45. Maybe I want the insert facing forward in this case. Maybe I want it facing back. The choice is yours, and every change you make, you get to see dynamically over here to the right. And the reason we get to see this dynamically is because in this option here, I have Show Machine Preview in Position activated. I'm going to green check mark that. Once I validate this, now the software is creating the angular solution required to do turning with my B at 45 degrees. Now we have another thing that we're going to have to do here as well. We're going to have to make sure to set the correct driven point of our tool. But first, let's look at our updated tool path. This is looking good. Now what I want to do is I'm going to go into my settings or my cutting conditions here. Of course, I'm going to reuse the same cutting conditions as before. So let me show you a quick trick for that. I can just drag and drop that over to here. That's going to copy all the cutting conditions. And from there, I'm going to come into my gauges. And now I'm going to do some magic here. And what I want to change basically is this. You can see how the tool is, and you can see where my cursor is holding onto the tool. I want to change the driven point of the tool because I need it to be that theoretical intersection of the cutting edge in X and in Z. To do this, I'm going to start by duplicating the driven point and changing to my duplicated point. The reason I do this with a duplicated point is this way I always have the standard system points available to switch back to whenever I need to. Okay, in the next roughing step, we're going to go ahead and rough out this area here. To do that, I'm going to zoom up, select my starting face, and I'm going to rotate my part a little bit, hold the Alt key, select my ending face. Right click, roughing again. Now, to start with, the software is of course going to try to rough it with the previous tool, which is that neutral tool that we had at 45 degrees. Now, here, what we're going to do is we're going to first switch to the groove roughing method up here. And now I'm going to switch tools as well. When I switch tools, I have another tool already in here. This is my standard 4mm groove roughing tool. Go ahead and look back. Now, the software is maintaining that B-axis angle for us. So we're going to come into here first, and now we're going to set some options. I'm going to zoom back out here for a sec, and I'm going to look at being with my B at 90 and my A, or orientation of my tool, at 180. You can see it here like this. This way, I'm using the tool offset to the correct side automatically. Next, I'm going to copy my feeds and speeds. Again, I'm going to use something similar, so why not? I'm going to copy those over. Let's go look, make sure everything came in the way we want. 750 surface feet, 15,000 per rev, max RPM of 3,000. If we look at our gauge points, we have a left and a right gauge point because it's a groove tool. That's perfect. We can come in here and we can play with any type of groove roughing we want. Now, we can use multiple control points. Okay, I can program with the left point and the right point. I can drive only by the left, only by the right. Of course, the choice is yours. If I go to the strategy tab here, I can choose the type of roughing methodology we want, including trichoidal roughing. Why not? Let's have a look at that option. With trichoidal roughing, I'm going to go ahead and set my radius and set my axial pass depth. Maybe here I only want to take 30,000th depth of cut. If I zoom up on the tool path, you can see it's going to lead in, it's going to cut, come back, and it's basically going to keep that tool engaged in cutting in a continuous fashion. Perfect. Like that, this operation is done. Let's let it update the stock model, and let's maybe take a look at the simulation. Cool. Now, as I zoom out here, you can see the tools coming in. Now, during a simulation like this, what's important too is the chuck, right? So if I look here, I can actually turn on the rotation of the chuck. And why would we do that? We do that because we want to see if there's going to be a collision at that moment of turning, right? So let's turn this thing on and let's see what happens here. So we're coming down, we're looking, and that gets close, and I'm going to go ahead and pause it. That gets close, but it never actually hits. Pretty cool, huh? If it did hit, this software would tell us about the collision. Awesome. Welcome back. In the next step, we're going to go ahead and finish this groove. I mean, we have the groove tool in the spindle right now. Why not do that? So here I'm going to, again, select, Alt select there, and here I'm going to go down to finishing. Now, just to be different, here's what I'm going to do. I'm going to change myself to the type of finishing we want to profiling. Okay, and here you can see again it grabbed that tool, but just to play with the lower turret, I'm not going to use this tool. Instead, I'm going to come over to my tool settings. I'm going to say, you know what, let's use our lower turret. And in my lower turret, I want to use that tool there. And of course, that's going to be the tool on the left side of my turret, and it's going to come in this way. Now, the tool path is offset here because on the machine, this is a slant bed lower. So what we would need to do, let me turn off the tool display here, is if we look at this, we can rotate down and you get a better idea of what's happening. Now, in this case, what I'd like to do is easy to understand. I want to program from two directions at once. So the tool is going to lead in, come down, come off, lead in, come down, come off. Cool. And from there, I also want to program by 2 points. Why not? This is for highly accurate tool path. Let's go set our feeds and speeds as well. Again, we want constant surface feet. Here I'm going to go up to maybe 800 surface feet, and I want a nice finish, so 5,000 per rev. I'll let this thing max out at 4,000 RPM. And we're done. And again, we get to see that simulation. Here the lower turret is indexing. It's going to approach, right? And now it's going to do its thing. And you can see the perfect little cut. Nice. Okay, in this next operation, we're going to go ahead and finish turn this front face, and this face. Okay, so here's what we're going to do. I'm going to start by selecting this to here. I'm only going to do that to begin with, and you'll see why. I'm going to go to finishing. I'm going to go ahead and I'm going to set myself back to the B axis of 45 because I want to go back and use our B axis. Why not? Now if I look at this in turning view, you can see good, looks good. I'm going to go to my geometry selection here, and I'm also going to add to it this face. Why not? So here I'm doing my cut, I'm coming in, doing my cut. I want to use similar feeds and speeds as that, so I'm just going to drag and drop them, and life is good. Like that, I've now finish turned everything. And again, we go into the simulation, everything's going to come down, and away we go. Nice. Okay, so at this point, we have done a lot of the turning of this part, right? We've used the upper turret, the lower turret, we've done a few operations, and now what I'd like to do is I would like to check how all of this is going to look, but with synchronization. And that's the important point here. So what I'm going to do is I'm going to switch to the final machining stage, and now I'm going to bring up my scenario down here. Now, if your scenario is not visible, like mine is, you can always turn it on by going to your 7 icon up here, going to view, and activating the scenario. Now down here, these are all of our various operations. Now here is the piece of awesome that I'm going to show you. I'm going to right click in here and choose automatic layout. And like that, TopSolid has now set all of the synchronizations dynamically. So now what we can do is we can just hit play. And when we hit play, you can see every operation that's going to happen in the order in which it's going to happen. And we can speed that up, you can slow it down, you can do with it as you want, you can rotate, pan, and zoom during the whole process. Everything is good. There's my groove roughing, nice. Here is the groove finishing, and here is my finish turning. And like that, our synchronizations look good. I would say that's a successful test. All right, now that we have the majority of our turning done, now what we want to do is we want to go ahead and do some milling. And maybe the milling features we're going to do are a little bit different. So what I'm going to do first, I'm going to minimize my scenario. I can always bring it back. I'm going to switch back to machining stage, and I'm going to continue working on this part. Now, to begin with, what I want to do is I want to mill out some of these features here. So I'm going to start by just selecting this face here, right-clicking on it, and going to end milling. Now, when I do that, the software is going to find the area to machine. It's going to propose it as an open pocket, which makes sense because guess what? It's an open pocket. And now we need to go find a tool. So I'm going to build a tool on the fly again just to show how simple it is to work with tooling in TopSolid. Here, I want to use this style tool, or maybe, you know what, I want to choose from a template. Maybe I want to use this style tool instead. So double click, perfect, that's done. And now here what I want is, how about a 3/8 diameter end mill? That looks good. Maybe here we want the 3/8 diameter end mill to have 3/4 of an inch of flute. Maybe it's 2 3/4 long. If I go to my advanced settings here, maybe this is a 4 flute tool. Great. I can go here and I can make changes to this as well. But most importantly, I'm going to come here and I'm going to play with my gauge distance. This is how far that tool is going to stick out. For example, here I want this to stick out 1 inch by default. Perfect. Let's go back to here really quick and let's maybe set some values for our holder, and you can see you can set this in any order you want. You can play with this all day long and then click OK and you have your tool. Awesome. Now as soon as we have our tool, of course since it's TopSolid, we have toolpath. So let's make some changes here. I'm going to go make some feet and speed settings. I'm going to say, you know, I'm going to run this at about 3,500 RPM and 50 inches a minute, maybe some jet coolant. That's awesome. I'm going to come down to my settings here and I'm going to set this to be maybe a 40% step over, and maybe we want a 1/16 inch depth of cut. Cool, why not? Don't need a spring pass. And maybe here we want to leave this with 10,000 stock on the floor, 10,000 stock everywhere else. Awesome. Like that, everything is good to go. Maybe last step I'm going to make is I want to use successive contouring. Cool. And away we go. And like that, TopSolid is going to update the stock model. We're going to see our simulation. It's going to rotate the B to the right angle. It's going to approach. I'm going to speed that up a little bit. Notice in this case, the spinning axis is the tool. Kind of cool. That way we can check even when the tool's spinning for collisions. Kind of nice. And away we go. Welcome back. In this next video, what we're going to do is we are going to take this toolpath and we're going to apply it down here. But how we're going to do that is going to be kind of cool. What I'm going to do is hold the control key down on my keyboard and just drag and drop that down to that face. When that happens, the software automatically finds the correct angular solution and creates the toolpath. I mean, that was easy, right? Let's drag and drop onto this face and see what happens. Here now the software is going to check against the kinematic definition of the machine. It's going to find the angular solution and it's going to create that toolpath. You know what? While we're here, let's rough out that pocket as well. I mean, why not? We have the end mill and the spindle. Let's do it. So now we have the pocket of that angular solution. And then next, let's take that toolpath, bring it over to this incline face. Cool. And then of course, we're going to drag and drop it onto the next face as well. And really what I want you to pay attention to is the fact that I've just programmed 5-6 operations in a matter of a few seconds on a 5-axis mill turn machine without worrying about anything. I mean, that's just awesome, isn't it? Welcome back. In this next video, we're going to verify the toolpath that we just created. Now, in TopSolid, when you go to verify, there's a couple ways to work. First of all, I'm going to just window select all the operations I want to verify. I can right click on it and choose verify. What's going to happen is kind of cool now. We're going to load into verify, but our verify is a bit cooler than most softwares because our verify also includes the full machine simulation. And you notice it was one click to get into. The other thing to notice is the stock is coming in at the exact moment it would based on all the previous operations. Kind of fun. So let's hit play and see what happens. Now, if you don't see the machine in your verify, it's just because you don't have machine simulation mode active up here. So just click that button and away you go. And here now, you can see everything happening in real time. And here, there's your pre-position move. Maybe I want to speed up the simulation a little bit. Cool. Now we're rotating, doing our thing, doing our thing. Perfect. Everything is seen in perfect simulated environment with zero collisions, zero problems, ready to go. Welcome back. All right, the next milling operation we're going to work on is going to be this 4-axis slot. Now, a lot of times in CAM softwares, they make machining harder than it really needs to be. I mean, if you think about it, a 4-axis slot is nothing, and it should be nothing. Now, here's how it works in TopSolid. What you're going to do is you're going to select the face to machine, you're going to right click, and you're going to go, yes, under 2D to end milling, because it's still just an open pocket, isn't it? So I'm going to go to end milling. Now, when I go to end milling, first thing I'm going to do is I'm going to come in here and turn on multi-axis. Now, multi-axis became available because of the definition of the machine. The machine knows we can do 4-axis work, so TopSolid is exposing more functionality. Here, I'm going to switch to 4-axis radial mode, and as soon as I do, boom, I get some toolpath. Awesome. Now, here what I want to do is I need to go in and change my tool because, in fact, this tool just is too big to work on that part. So I'm going to come in, use slot mill, double click, and I'm going to search for a different tool. I want to use a 1/4 inch end mill. And here maybe I'm going to use this one here, nice little extension tool. Perfect. We'll go ahead and validate. And like that, you're now going to see the wrapped toolpath. Now, what's even cooler than that is, again, how quick everything is happening. Now, here's one little thing. You can see here it generates all the toolpath, but TopSolid doesn't know where to start with the toolpath, so we go all the way to the extent of the part. So here, you still got to be a little bit of an NC programmer. We're going to come into the Altitudes tab, and all we're going to do is change our starting altitude to be at a specific point. And what point? I'm just going to zoom up, and I'm going to find one of the endpoints here of the profile. Perfect. Like that, it's now going to measure that radially. I can come in and I can set my depth of cut, my step over depth of cut. I can set maybe this I want to be 60 thousandths. Cool. Maybe I want to leave 10 thousandths here. Maybe I want to leave 10 thousandths on the wall. Awesome. But at the end of the day, we have now successfully just made a 4-axis toolpath. And what's even cooler than that is, of course, we simulate everything. You get to see exactly what's going on and how. And notice it's plunging off the slot in the open area automatically because that's just the right way to cut a feature like this. And the best part about all of it is you didn't have to think hard to get there, did you? Nice. Okay, next we're going to move on to some ID work. So before we do that, I'm going to go to my turning tab. I'm going to turn on a really cool feature called part display. And here I'm going to enable turning preview. And with turning preview, I'm going to set that to 90 degrees because I still want to see my finished part as well. And like that, I can now see the inside of my part. Nice. So here, I want to start by drilling down the center of this. So I'm going to right click on this, go to hole machining. Right now it said this is a 2-inch bore. Okay, so what I'm going to do is I'm going to go ahead and look for a flat drill, and maybe we'll build a flat drill. Why not? My flat drill, I don't want a 2-inch, I want a 1 3/4 inch. Okay, or maybe, yeah, 1 3/4 inch is good. If I look at this straight on, that's got enough flute length in it, right? And that's going to go right to that depth, and that's good enough for me. Perfect. Now, from here, we need to program it, right? So I'm going to set how I want this to work at. Maybe I want this to be running at 500 RPM and 15 inches a minute with through the spindle coolant, right? So I'm going to go through center coolant. Next, what I want to do is I want to choose what's spinning. Is the part spinning? Is the tool spinning? In fact, you have the control right here for that. If I leave it like this, it's the tool that's going to spin. If I choose this, it's the part that's going to spin. Or I can double my feed rate and choose both the tool and the part. Now, this is specific to your machine. If your machine allows you to do this, great, choose it. If not, choose one of the others. In this case, I'm going to say that this is a static boring bar and I want my part to be spinning. Awesome. Like that, I'm going to click OK. And again, we're going to come in, do our thing, and come out. Nice. Now, maybe you're noticing that the way this approached was not very safe because it's getting really close to our turret here. Now, the turret was still safe, but maybe you want to change that approach move, right? So here's what we're going to do. In the next video, I'm going to show you how to edit a link movement. Okay, now in the last cut, again, let's watch the simulation here. You're going to see that this is going to come down, right? And it looks like it's getting close to that turret, the lower turret, I should say. And if I pause that, I mean, you can see that it doesn't. But it's enough to make most operators cringe. So maybe what we want to do is we want to approach with the B-axis up here first and then come down. So how do we change that in TopSolid? Well, thankfully we have something called link movement editing. So here I'm going to right click on the operation, go to link movements and say edit approach. When I do this, I'm going to turn off automatic mode and go to manual mode. Now here is that first move. Now the first move here is setting A and B correctly. Perfect. The second move is moving this down, then moving over, right? And when we move over, it's moving to a rapid plane. So why don't we just move that one up? Yeah, it was that easy. Again, orient the part, approach in Z, approach in X, and finish. That was nice and simple. We didn't have to think too hard. Now if we simulate, way better approach move. And again, it's you that had the control to tell TopSolid what you want to do and how. Okay, next I want to do some ID turning. Now in this case, I need an ID, and I need a turning tool, in fact, that can reach down the length of this part, right? Now I remember that I used this tool on a similar part in a different job. So instead of going through my database and hunting for the tool, which of course you can do, I'm going to instead go back to my start page here and I'm going to load the project where I know I have the tool already. Here I have one called teaser. I'm going to double click and lo and behold, it's the same part. The only difference is instead of it being on an Okuma, it's on an Integrex. In this case, what I want to do is go to my tool manager. I'm going to find the tool in question. I'm going to make sure it's the right tool by turning on visually. Yep, there's my tool I want to use. And here's what I'm going to do. I'm going to right mouse button click on it and choose copy. I'm going to hit the green check mark here. I'm going to switch back to my current CAM project. Go to the equipment tab. Go to my tool manager. Make sure I'm in the right place. I want to be on my spindle. Okay. And go to the next available pocket and choose paste. I'm going to choose no to that because I don't care about it being in the same pocket. And like that, my tool is now in this project ready to use. Last thing I'm going to do, go back to this part and I'm going to close it because I don't need it open anymore. And like that, you just learned how to reuse tooling made in a different project and bring it forward into another project. That was easy. Okay, next we're going to go ahead and do our ID turning. To do that, I'm just going to zoom up here. And I'm going to put myself in a turning view because it's just more fun. I'm going to choose this face, hold my Alt key down, choose this face, or right mouse button click, and I'm going to go to roughing. Now, when I do that, it's going to grab my neutral tool in my B-axis because that was the last time we used it on the B-axis, and then we're going to have to go and choose the tool we want to use. So let's go to here, and let's switch to this tool. As soon as we switch to this tool, we're going to see better visualization, and of course the software is going to find the right area to machine. Now, the other thing we want to do is we want to set our B-axis angle, obviously, to be horizontal. So we want the B to be at 0, the A to be at 0, and we're good. Now, in this case, the software sees all the material, right? But we don't want to go all the way through there because if you look by this tool, we can reach about to there. So that's exactly where we want to stop it. So let's go to our settings, and we're going to go set a limitation point, similar to what we did on the first as well. So we'll go to stock to leave and limits. I'm going to switch to in Z. I'm going to pick a point, and maybe I'm going to start by using this same point. Let's see what happens. If I turn that off and bring the tool back, that's still a little bit too deep, isn't it? No big deal. Let's go back to here and pick a different point. Maybe I choose this point right here. Let's look again at the visualization. Oh, that looks good. I feel good. Next, what I want to do is set my feet and speeds and move on. So again, I'm going to use constant surface feet. Why not? Here I'm going to use maybe 600 surface feet, and I'm going to use 10,000 ship per rev and 3,000 RPM, and like that, we're done. And we have perfect toolpath. Nice. Okay, from here what I want to do is I want to finish turn the ID. So again, same tool, select the start face, select the end face using the Alt key, and I'm going to go to finishing. In this case, tool is going to come down, it's going to do its thing, and come off. Perfect. I'm going to use similar feeds and speeds, so I'm going to copy this to here. The only difference in this case that I'm going to worry about is, you know what, I want a nicer finish, so I'm going to go to 5 thousandths, and that's it. And now it's going to come in, do its thing, and oops, look at that. That was a bad retract. Shame on TopSolid. Well, even our software gets it wrong from time to time. But if that happens, no big deal. Go to Link Movements. Let's edit the retract. Let's go into here. Let's turn off automatic, go to manual, and check it out. Boom. And I bet you that sends Z home next. So guess what we're going to do? We're going to send Z home first, and then the rest. Again, you're always in the driver's seat. You always get to control TopSolid how and when you need to. Okay, from here what we're going to do is some ID milling. So let's go have a look in here. And what I want to do is I want to select this face here, and I'm going to go to end milling. When I do that, software is going to grab the last end mill that we used, which happened to be a 1/4 inch end mill. Perfect. Now here, what I want to do, I'm going to leave this at 0, and maybe I want to rough this at 60 thousandths depth of cut. Did you guys notice, by the way, that it is picking up every single ID pocket automatically for us? I mean, think about that. How cool is that? And if we look at this, this is great. This is doing everything in that pocket. Now, in some cases, on machines like this, doing that type of work is great, but you might get some over travels. Okay? Why? It's because these machines maybe don't have the biggest y-axis travels. Okay? Or you can't go below X to a certain level, or whatever. In cases like that, what you want to do is you want to switch from using XY machining to polar coordinate machining. Okay, so all I'm going to do is go edit this operation, and we're going to go again to that multi-axis button. We're going to activate multi-axis. We're going to be 4-axis axial, and we're going to go to transformation from milling to turning. I'm also going to initialize the axis at 0 degrees, and that's it. Now we're going to use polar coordinate machining, and let's have a look at what that looks like in simulation. Okay, so the toolpath is done. Let's go ahead now and run simulation on this. And now watch what happens. We're going to approach, we're going to do our thing, but this time something different is going to happen. Notice the C-axis is moving now instead of the XY axis. Cool. Again, you didn't have to delete the toolpath, start over. All you did is activate the command you were after. Very, very easy and awesome. Okay, let's do some finish milling then. Why not? So just like we did before, I'm going to come in here, I'm going to choose this face, and I'm going to choose side milling. When I choose side milling in this case, it's going to go ahead and it's going to find the profile of everything again. I mean, awesome, right? I'm going to do this at 1 depth of cut. Why not? But instead, maybe I want to take multiple radial passes. So let's do that. I'm going to come in here and I'm going to say my first pass is going to be at, let's say 20 thousandths, and my final pass is going to be at 5 thousandths, and let's take as many as we need. Let's say 3, I don't know. And boom, if we look, it's going to take 2 passes. Cool. Now, I'm going to use polar coordinates as well because I just like using polar coordinates for this type of machining. So why not set it correctly on the fly? Again, I'm always going to initialize that C-axis to 0 because it's just a safe thing to do. And then I'll go ahead and set my feeds and speeds because, of course, we need feeds and speeds, right? So I'm going to say, this is going to be running at about 4,500 RPM and 50 inches a minute. I like that. Cool. You can also do it by chip load. Maybe I want a 5,000 chip load. Nice. Jet coolant. Done. Ready to rock. And yes, it is that easy. We're going to go ahead and go back into our simulation. We're going to move on. And notice again, we're using the C-axis appropriately to finish all of these features. Now, in the next movie, we're going to do some 5-axis continuous milling. Okay, in this next video, we're going to go ahead and learn how to do some basic 5-axis milling. Now, I want to be super clear here, guys. This is a demo part, so everything is perfect on my part. What I'm going to do here is I'm going to go to swarf machining. Up here, I'm going to choose the type of swarf I want. I'm going to use the last method, face machining. This is intended for simple face machining. I'm going to select right here. You can see it previews the tool in position already. Perfect. If it was going the wrong way, invert it here. If you're going the wrong ISO curve, flip it there. Perfect. From here, all I need to do now is set my tolerances and my feeds and speeds. So let's go ahead and set my feeds and speeds. Maybe this we're going to run at about 6,000 RPM, why not? And maybe at about 80 inches a minute. And we're going to use center coolant on this one. And then from here, what we want to do is I'm going to go ahead and say my maximum depth of cut here is going to be big. My stock leave on the floor is going to be minus maybe 40. I want to stick out past the bottom of this detail a little bit. Stock leave on the wall is 0. Good enough. And we're going to hit go. And I'll watch what happens. Here we're going to come in. I'm going to slow this simulation down really quick. It's pre-positioning to where it needs to be. We're going to come it back in, and like that, you just did 5-axis swarf milling. Cool. Doesn't get easier than that, does it? We're done. Okay, next we're going to do some more ID work here. Okay, we have these features in here. And just to be able to see it a little bit more cleanly, again, I'm going to go activate that really cool visualization tool, turning display. So if I look at this straight on, you can see we have this at some kind of inverted inclined plane. And the engineer who made this was nice enough to at least create a little flat face for us first. So let's go ahead and machine out that first, and then we can talk about drilling this detail. So it doesn't really matter which one we start on. Maybe I'm going to start on this one. Let's start here and just go to end milling. Cool. Now, right off the bat, you're going to see that we don't see anything. That's because our tool is too big. Well, how do we define or decide what size tool do we need? Well, we can always, in the middle of any command, go to the Analysis tab, go to Measure, and go get the size. Maybe I just want this radius size. So that's a 3/16 diameter. So if we use an 1/8 inch end mill, that should be good enough to machine here. So let's go ahead and find us an 1/8 inch end mill. Now let's see if I've made one before. So I'm going to set my filter, I'm going to come down to here, and I'm going to choose 1/8 inch. Perfect. And here we can see I have a nice 1/8 inch tool. I like it. We're going to click OK. And like that, we'll now have our tool path ready for that move. Now, let's pay attention, because right here, notice that the angular solution the software found has it rotating to work down at the negative side here. Let's just click OK once, and let's see what happens. When we do this, it's going to go obviously into the simulation mode. Now, let's zoom out. Let's watch the move. Here we're pre-positioning, right? So we'll speed up a little bit. Pre-positioning B, pre-positioning C. We're approaching, and we're doing our cut. Okay? That's nice. But there's another solution, and this is something that's awesome about TopSolid. TopSolid will give you every angular solution it finds. What do I mean? Well, first of all, we're machining with the tool in this orientation. If I go to my WCS solutions here, it's giving me the opposite angular solution as well. What does that mean? Well, let's click on it and take a look. Here now, it's going to flip C, invert B. Why? Because we can. Okay, let's look and see what that solution looks like. Maybe it's the better way to work for what we're doing. Who knows? Let's run a simulation. When we run the simulation, now notice B is inverted actually. We're going to do our approach, and we're going to machine the part. Again, it depends on who you are and what you're doing. It depends on the strokes of your machine, how far can you rotate these axes. But what's awesome about this is that TopSolid gives you every possibility that this machine is capable of doing. And it does it effortlessly, which makes your job a bit more effortless as well, doesn't it? Okay, from here, now we're going to do something even cooler. We're going to use a repetition to repeat that positional toolpath. But the repetition that we're going to use is not repeating the toolpath. We're going to repeat what's called the WCS. The WCS stands for Work Coordinate System. Now, in this case, again, we want to take this toolpath, this inverted toolpath, and we want to repeat it 8 times. Now, again, to make the visualization simpler, under my turning tab here, I'm going to come in, I'm going to turn off part display. Next, what I'm going to do is I'm going to select the WCS, that angular solution, and I'm going to right click on it and go to repetition and create a repetition. Next, the type of repetition I'm going to create is going to be circular, about my absolute Z, 360 degrees, with 8 instances. I'm going to turn off alternated numbering because I don't need this in this case. Now, you're going to see all those toolpaths. Cool. Like that, we have now made a repetition of everything. Now, the software needs you to recalculate this toolpath. So you come up here and you hit regenerate. So we do the repetition, then we hit regenerate, then it updates the stock model, and like that, you have quickly machined all those features. The next video, though, you're going to see something even cooler than just this repetition. So now the calculations are done. If you mouse over any of these, you're going to see all of these solutions. If you want, we can take all of these things quickly. I'm going to hold Control, select the Simulate button. That's a little hidden magic trick about sending something into Verify. Okay, and now we can run Verify on this. And now you can see it's doing its thing. Perfect. Okay, from here now, we want to do the drilling on here, but I want to be super clear about something. I want to do the drilling based on starting from the same position, and you'll understand why here in a second. So I just turn on the toolpath to mark where I'm working. So I can come over here, go to drilling, go to hole machining. When I go to hole machining, I want to be working at the same 45 B-10 because I want the same WCS, in fact. You can see here the software selected that automatically because I have other operations used for it. Perfect. Here, I'm going to go to pick a drill. Let's go double click. You could of course do a centering operation, whatever. You guys get the idea at this point. I want my 1/8 inch diameter drill. Perfect. This needs to be, let's say, 1 3/4 inches long that way. Maybe it's a 3.5 inch long drill. I like that. Maybe we'll go ahead and look at the shank diameter here at being 1/8 inch as well. And we'll come here and say this is maybe 2 inches long. Nice. That looks like that'll be good. Might have a collision. Let's see if we have a better holder. Let's use an extension holder instead. Probably a better choice. I'm going to double click to make that change. Again, I'm going to make this 1 3/4. I'm going to make this 3.5. Cool. We'll set the shank diameter to the 1/8 inch. Let's set the extension portion of the holder to maybe 3/4. Maybe this is 2 inches long. Let's have a look. Yeah, that's looking better already. And you get the idea. Now, come in here, we'll set our feeds and speeds. I want this to be 2500 RPM, and I want this to be at 15 inches a minute jet coolant. I'm going to go into my settings even, and I'm going to set a pecking routine. Why not? So I'm going to come into here, activate pecking, set our peck depth to 100 thousandths. Why not? I like it, and go. Now, here's where the magic happens. Not only did we just drill that hole, okay, because we totally did, but if we look, we just drilled all the other holes as well. The fact that I had a WCS repetition active for that position means that by default, every single toolpath associated with that WCS solution will also auto-repeat, making your programming process even faster. All you need to do is hit the regenerate button to calculate all the repeated features. All right, we're nearly done with this side of the part. I got some drillings to do and some finish millings to do, so I'm going to go ahead and just finish this part. So what I'm going to do is I'm going to start by finish milling this. So I'm going to go to side milling. When I go to my side milling, That's going to pick my 1/8 inch tool because that's the last end mill I chose. Maybe we want to change this to be a different tool. Let's use our 1/4 inch tool. Why not? Perfect. Let's also go and set the angular solution we want. It's just a little bit confused right now. So let's go ahead and choose Create on Face. Let's choose this. We have our 0, 0, which is perfect. Click OK. And now we have the proper angular solution. You also see here when I do this, it wants to machine back here because there's material. It's normal. Let's just say machine the local feature instead. Perfect. And then the last thing we want to do is I want to, in one shot, I want to finish the walls and I want to finish the floors. Okay, so how can we do this? Well, we can do this by doing radial passes. I'm going to say that my radial passes here on this tool are going to be worth about 100 thousandths. Okay, with the last one being at 20. Why not? I'm going to say take as many as you need. How about I type 10 and see what happens? And here you can see it's just going to take as many passes as is needed on the floor. Now the other thing I'm going to do is I'm going to play with my lead and lead outs here, just for giggles and grins again. I'm going to say, you know what, a 45-degree move there is good. 50 thousandths lead in there is good. Boom, I like it. Let's just be done. And like that, I've now finished that side. And of course, you know where I'm going to go with this next, right? Next, what I want to do is I'm going to take this tool path, flip over, I'm going to drag and drop it down to this wall here. Why not? It's going to go to the right WCS solution, create the tool path, but again here, went a little far. Again, it's the default nature of TopSolid to try to do everything it possibly can. Ironically, because we're between the jaws here, you suppose you could let it machine back there if you really wanted to, but I don't want to do that. I'm going to switch back to local mode. Perfect, done, move on. Nice. You can use these same methodologies to finish these features in here as well. The drillings that you saw me do, same features as well. Okay, so what I did in the past few minutes was I programmed a whole lot more of this part. I just want to review with you what I did. Where we worked together, we did this side milling and this side milling together to show you how to finish. And then I just went crazy using the same technologies I've shown you already to machine all the rest of these features. So let's have a look. I'm going to start from here, go all the way down to here. I'm going to do this within Verify, just so we can see everything. And we'll watch the material removal as well. So here, I'm going to zoom out a little bit. I'm going to hit play. And we're going to see that's going to finish up that face. It's going to pre-position, finish up that face. We're going to finish that pocket floor, finish that pocket floor, finish that wall, finish that wall. Sweet. Now, next, we're going to center drill. Next, we're going to drill. Notice I'm pecking. Awesome. And then we're going to finish using helical contouring the contour bore. Nice. So those are all those operations, and those operations were done using the same methodology that I've shown you in other videos. And it took me maybe, I don't know, 4 minutes, 5 minutes to do all those ops. Cool. Okay, the last feature we need to program on op 1 of this part is the radial drillings. So how do we do that? I'm going to zoom up, select a hole, right click, go to drilling just like you normally would. Now to begin with, what I'm going to do is I'm going to switch to tip drilling. Okay, I already have a tip drill in here. The diameter of this hole is 1/4 inch, and I want to leave a little chamfer on here, so I'm going to set it to 275. This way we leave a small chamfer. Now, how do I get it to find all the other holes? Well, it's simple. You turn on multi-axis. We make sure that we go to 4-axis radial. Then we can go to the geometry button, and we can hit find its brothers and sisters. I'm going to hit no to that. And here, TopSolid is going to automatically find all the other ones. Now, word of the wise here, I'm going to come down here to optimization and force it to always go either C positive or C negative with the rotation. Like that, you've just done radial drilling. The same operation would apply for actually drilling the holes as well. Okay?